Hi, I'm Patrick Regan. This video, Part 0, Decimal and Binary Conversions, is a supplemental video that will be useful when understanding TCP/IP addressing and subnetting. It discusses how to convert between the decimal, binary, and hexadecimal number systems. With any of my videos and the wonderful technology that we have today, don't be afraid to pause the videos if you need to study the screen or you need time to do the calculations yourself. You'll need the pauses, particularly for this video. The most common used numbering system is the decimal number system. In a decimal numbering system, each position contains 10 different possible digits. Since there are 10 different possible digits, the decimal number systems are numbered with base 10. These digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. In order to count values larger than 9, each position away from the decimal point in a decimal number increases in value by a multiple of 10. As you can see from the table, the rightmost digit is the 1 place. The next digit to the left is the 10 place. We then have the 100 place, the 1000th place, and so on. We break this down mathematically. Yes, gotta love that math. The 1 place is represented by 10 to the 0 power, which is 1, and the 10 place is represented by 10 to the first power, which is equal to 10. The 100th place is represented by 10 to the second place, which is equal to 100, and so on. If we take a decimal number, 234, the 4 is the 1 place, the 3 is the 10 place, and the 2 is the 100 place. While this may look obvious to us because we use it every day, the emphasis of this concept is used in binary numbers. The binary number system is another way to count. The binary system is less complicated than the decimal system because it only has 2 digits, a 0 and a 1. A computer represents a binary value with an electronic switch known as a transistor. If the switch is on, it allows current to flow through the wire or metal trays to represent a binary value of 1. If the switch is off, it does not allow current to flow through the wire, representing a value of 0. The on switch is also referred to as a high signal, while the off switch is referred to as a low signal. If you use 2 wires to represent data, the first switch can be on or off, and the second switch can be on or off, giving you a total of 4 combinations or 4 binary values. If you use 4 wires to represent data, you can represent 16 different binary values. Much like decimal numbers, the binary digits have placeholders that represent certain values. So the rightmost value is 2 to the 0 power, which is the 1 place. The next digit to the left is 2 to the first power, which is the 2 place. The next digit is the 2 to the second power, which is the 4 spot. So as you can see, we double each value going from right to left. 1, 2, 4, 8, 16, 32, 64. So the 8th digit, or 2 to the 7th power, is the 128th spot. So, if you convert 1110, 1010, you can see that the first one goes to the 128th spot, and the second one goes to the 64th spot. We have a 1 for the 32 spot. Since we have a 0 for the 16 spot, we put a 0 there. We have 1s for the 8 spot and a 2 spot. We then add them up and we have 128 plus 64 plus 32 plus 8 plus 2, which is equal to 234. Note, to help with the readability of the binary numbers, it's often written with there's a space between every 4 bits, similar to adding commas to decimal numbers. Therefore, 1110, 1010 will be written as 1110 space 1010. So let's look at a different way to convert a binary number to decimal number. You would then write down 1 at the bottom and keep doubling until you get to 128. You'll then write down the binary digits, start from the top to the bottom. Then, wherever you have a 1, bring that value over. When you have a 0, bring a 0 over. You're now ready to add these numbers. 128 plus 64 equals 192. You then add 32 to the 192 and you have 224. You then add 8 to 224 and you have 232. Lastly, you add 2 to the 232 and you have 234. Therefore, 1110, 1010 is equal to 234. Let's take a look at another example where we need to convert 01001011 to a decimal number. So start writing down 1 at the bottom and keep doubling until you get to 128. Then write down the binary digits from top to bottom. You then bring over the numbers wherever there's a 1. Then add them up together. 64 plus 8 is equal to 72. Add a 2 and you got 74. Then add 1 and you have 75. So the binary number of 01001011 is the decimal number 75. Question: what is the decimal number for 11111000? Answer: 248. Question: what is the decimal number for 11000000? Answer: 192. Question: what is the decimal number for 11110000? Answer: 240. Question: what is the decimal number for 11100110? Answer: 230. Question: define the decimal number shown on the screen. Answers 0, 128, 192, 224, 240, 248, 252, 254, and 255. Now to convert from decimal to binary number, you will do the following. First, start in the bottom left corner, you would write 1 and double each time until you have 8 digits or you reach 128. To give some space and write 234 higher than the 128. Can you subtract 128 from 234 and still have a non-negative number? Yes. So you put a 1 down next to 128 and subtract 128 from 234. Next, can you subtract 64 from 106 and still have a non-negative number? So yes, put a 1 next to 64 and subtract 64 from 106. Next, can you subtract 32 from 42 and still have a non-negative number? Yes, so put a 1 down next to 32 and subtract 32 from 42. Can you subtract 16 from 10 and still have a non-negative number? No, so put a 0 next to 16. Can you subtract 8 from 10 and still have a non-negative number? Yes, so put a 1 next to 8 and subtract 8 from 10. Can you subtract 4 from 2 and still have a non-negative number? No, put a 0 next to 4. Can you subtract 2 from 2 and still have a non-negative number? Yes, so put a 1 next to 2 and subtract 2 from 2. If there's no numbers left, you can put 0 for the rest of the binary digits. But if you follow the rules, can you subtract 1 from 0 and still have a non-negative number? No, so put a 0 next to the 1. So the binary number is 1110, 1010. Now, let's convert 75 to a binary number. First, in the bottom left corner, you would write 1 and double each time until you have 8 digits or you reach 128. Then, give some space and write 75 higher than the 128. Can you subtract 128 from 75 and still have a non-negative number? No. So put a 0 next to 128. Next, can you subtract 64 from 75 and still have a non-negative number? Yes. Put a 1 next to 64 and subtract 64 from 75. Next, can you subtract 32 from 11 and still have a non-negative number? No. So put a 0 next to 32. Can you subtract 16 from 11 and still have a non-negative number? No. So put a 0 next to 16. Can you subtract 8 from 11 and still have a non-negative number? Yes. Put a 1 next to 8 and subtract 8 from 11. Can you subtract 4 from 3 and still have a non-negative number? No. Put a 0 next to 4. Can we subtract 2 from 3 and still have a non-negative number? Yes. Put a 1 next to 2 and subtract 2 from 3. Can you subtract 1 from 1 and still have a non-negative number? Yes. Put a 1 next to 1 and subtract 1 from 1. So the binary number is 01001011. Question: what is the binary number for 224? Answer 11100000. Question. What is the binary number for 240? Answer 11110000. Question. What is the binary number for 178? Answer 10110010. Now, let's discuss hexadecimal numbers and hexadecimal number conversions. A hexadecimal number system has 16 digits. One hexadecimal digit is equivalent to 4-digit binary numbers, 4 bits, or a nibble, and 2 hexadecimal digits are used to represent a byte, or 8 bits. Therefore, it's very easy to translate between hexadecimal and binary and used primarily as a shorthand way of displaying binary numbers. Similar to decimal numbers and binary numbers, each position will be defined 16 to whatever power based on its position. The first position is 16 to the 0 power, which is 1, and the second place is 16 to the first power, which is 16. The third place is 16 to the second power, so it is 256, and so on. Question. What is the hexadecimal number of the binary number of 10011010? Answer 1001 is equivalent to 9 decimal number, which is equivalent to 9 hexadecimal. 1010 is equivalent to 10 decimal, which is equivalent to the A hexadecimal. Therefore, 10011010 has the hexadecimal equivalent of 9AH. Let's convert the decimal number 175 to a hexadecimal number. So first, convert the 175 to binary, and then convert the binary to a hexadecimal number. So start writing the 1, double each time until you get to 128. Write down the 175 and ask yourself, can you subtract 128 from 175 and still have a non-negative number? Yes. So put a 1 next to the 128 and subtract 128 from 175. Next, can you subtract 64 from 47 and still have a non-negative number? No. Put a 0 next to 64. Can you subtract 32 from 47 and still have a non-negative number? Yes. Put a 1 next to 32 and subtract 32 from 47. Can you subtract 16 from 15 and still have a non-negative number? No. Put a 0 next to 16. Can you subtract 8 from 15 and still have a non-negative number? Yes. Put a 1 next to 8 and subtract 8 from 15. Can you subtract 4 from 7 and still have a non-negative number? Yes. Put a 1 next to 8 and subtract 4 from 7. Can we subtract 2 from 3 and still have a non-negative number? Yes. Put a 1 next to 2 and subtract 2 from 3. Can you subtract 1 from 1 and still have a non-negative number? Yes. Put a 1 next to 1 and subtract 1 from 1. So the binary number is 10101111. Now that we have the binary number, we can convert the binary number to the hexadecimal number. 1010 is equivalent to 10 decimal number, which is equivalent to a hexadecimal. 1111 is equivalent to 15 decimal number, which is equivalent to f hexadecimal number, which gives us in its entirety AFH. The H indicates it is a hexadecimal number. Question: what is the hexadecimal number for 240? Answer: F0H. Question: what is the hexadecimal number for 178? Answer: B2H. During the Network Plus exam, you will not be allowed any type of calculator. And if you had to take the Cisco CCNA exam, you'll have to do these calculations quickly as it is essential for the exam. However, in everyday situations, you can pull up a binary converter site or you can use the Windows calculator. In Windows, to convert from a decimal number to a binary number, you would open the Windows calculator and change to programming mode. Click Dec, which is short for decimal number. If you enter 158, it will show you the hexadecimal number, octal, and binary. You can also click Bin at this point and cut and copy the value. To convert a binary number to one of the others, click Bin. You can then type in 01001011 and it will show you the hexadecimal, decimal, and octal numbers. To convert from hexadecimal to binary, just click Hex and type in the numbers such as 9A and look at the conversions. For more information, visit the following sites. Thank you for watching this video. The next video will be TCP/IP Part 1, the TCP/IP Suite. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.